to look at the stuff that we've already been doing, but we're going to add an extra layer of complexity. So first of all, let's just make this a bit thicker. Okay. So find the first three terms. All right, we know how to do that, but I'm going to make it worse.
Could you? No.
All right. So I'm going to make this worse. Normally, we've just had this. We've got an extra bracket on the front, okay? So it's not as bad as it seems. There's just another layer, another step that you have to do at the end. So it's not actually that much worse. There's just, because there's more steps, there's more opportunity to mess things up, right? So I think someone described this the other day as tedious, which is kind of the point, right? It's not that hard, but there's so many small steps and so many opportunities to make a mistake. It feels frustrating. So we're going to ignore the x plus 4, all right? So we are just going to worry about this bit. So if I want the first three terms, what's my first term? X to the power of 6. What's my second term? Good. Why did I write 2? Okay, so what's the coefficient? 6. Good. Oh, geez. So I've got x to the power of 5. Actually, I'm going to slightly rewrite that. So then I've got 5x to the power of 5. Sorry. Oh, yeah, it's 6 anyway, isn't it? Oh, you're welcome. Come on. This is why I need a new laptop. Okay, and what's my second term? 2 over x. All right, so what's my third term? What's the coefficient? 15. Then I get x to the power of 4 and 2 over x squared. Okay, so I'm just going to worry about the first three terms. Okay, so let's work it all out. So that's x to the 6. What's this one? Okay, so let's just think about it like that for now. How do I put this together? Okay, so I want you to think about what this is going to look like, right? You can think about it like this. Can't you? Right, I'm just multiplying that by this. So this is 12x to the power of 5 over x. So what happens with the x's? Right, this becomes 4. Right, so think about your index rules. I'm just going to erase all of them. I'm going to erase all of that so I can actually write it in. No, that's what I wanted. So then, how does it always do that? Ah, give me the pen. All right, so this is 12x to the power of 4. Okay, because that is going to be cancelled out. One of these is going to disappear off that, and it's 6 times 2. Let's apply this same thing to here. So what number goes here? 60. How did you get 60? Right, this is 2 squared, and then 15 times 2 squared. So 15 times 4 is 60. How many x's have I got? 2, because this is x to the power of 4 divided by x squared, which leaves me with x squared. Seeing what I'm doing? All right, so I have these 3 as my first 3 terms. Now what I'm going to do is add back this. So now I have x plus 4 times all of this stuff. Right, so now this x needs to go on all 3 of them, and this 4 needs to go on all 3 of them. It is so many numbers, isn't it? Let's just move it up a bit. All right, so then I get x to the power of 7 plus 12x to the power of 5 plus 60x cubed. Now 4 is going on all of them. So 4x to the power of 6 plus 48x to the power of 4 plus 240x squared. Now, if I'm asked for the first 3 terms, which is what they asked me for, how do we normally write this? Do I just pick the first 3? What do I do? Ascending order. So I've got to the power of 7, to the power of 6, to the power of 5. So actually, my first 3, whoops, sorry, I'm writing it in the wrong order. My first 3 terms are these. So those are the first 3 terms of this binomial expansion. So when you've got something like that, just do the one with the power first, right? Get your 3 terms. Then do this out the front and then figure out which ones you actually need. Frankly, you could write out all 6. That would be kind of a waste of your time.
Also,
Is there a shortcut? No. We wish.
can we make one?
Can you make up a shortcut? Sure, go for it. See if it works.
Like-
If you can come up with a shortcut, you might win a mathematics Nobel Prize or something.
Like they come up with one and you mark them as right on the test.
Oh, really? That's a very optimistic way of you to think about this. Okay, let's save that. All right, let's have a look at another example where I'm going to ask you for a particular coefficient. Okay, this one is really rough. All right, you think that one was great in comparison to what we're about to do. So,
Really?
oh yeah. No, but I'm going to give you the answer and ask you to find something weird in the middle, which is worse. So I'm going to tell you that the coefficient of x cubed is 560. Okay, so I'm giving you the answer this time. Usually you're asked to find the coefficient. Now I'm going to give you a binomial thing with a letter in it, and you have to figure out what that letter stands for, okay? Again, it's the same rule. We're not learning new rules. We're just kind of reverse engineering it a bit. That is not how you spell coefficient. Coefficient. Ugh, I can't write and speak at the same time. Okay. Okay, so we need to find out A. Okay, I know. So what we're going to do is we're going to start exactly the same way that we started before. So what I'm going to do is I'm going to find my first 3 terms of this. Actually, I'm going to find my first 4 terms. Why? Tell me why I'm going to find my first 4 terms of this. Because I want x to be cubed. This is my second term, so I'm going to start at 0. No. So I'm going, so this is the second one, right? So I'm going 0, 1, 2, 3. So it's my 4th term that has an x cubed. So you could keep going, but that would be a waste of your time. So I'm going to say that my first 4 terms are 2 to the power of 7 plus, what's my coefficient? 7. And then I've got 2 to the power of 6. Hate when it does that. Shut up.
Oh, no.
Okay, whatever. And then I've got negative x, and that's to the power of just 1, right? What's my next coefficient? 21. Then I've got 2 to the power of 6. Oh, no, 6, 5. Ugh, 5. And then I've got negative x to the power of 2. All right, I need to get this to 3. So what's my next coefficient? 35 gives me 2 to the power of 4 and negative x cubed. All right, so let's get all of that expanded.
Is it supposed to be ascending or descending? Because the last one you saw was descending.
I'm not sure what you're asking. All I want is the coefficient of x to be, sorry, I need my x cubed term. Yeah, so the first one goes down, the second one goes up, but I'm interested in my x cubed term.
Yeah.
So that's just all I have to do. Okay, so this gives me 128 minus 448x plus 672x squared minus 560x cubed. Okay, so I've got my first bit here. Now, here comes the weird bit. So what I now know is, so before when I got to this stage, I then just multiplied it by this. Okay? Okay, but with this one, what's going to happen is I'm going to multiply. I'm going to multiply by these. So let me just write out what I want to do. I'm going to change color. All right, so now I'm going to add in this bit. So what I'm going to do is I'm going to, all I'm interested in is any time I have an x cubed term, right? That's all I care about, x cubes. So if I multiply 1 by any of these things do I get x cubed? This one here, right? So I care about this one. So that's going to be 1 times this. If I multiply ax by any of these, am I going to get x cubed? This one here, right? So this is going to be 672x squared. If I have 2x squared, what do I multiply it by to get a cubed? This one, right? So plus 2x squared times negative 448x. So I only care about these three terms because this is the only way I can get a combination where I end up with x cubed as my term. Are you with me? Okay, so all I'm doing is selectively drawing the bits out that matter to me because I'm not being asked to expand everything. I'm just being asked to care about the x cubed bits. So let's, what I'm really saying here is that first of all, this is just that, right? Sorry?
Like 2 times negative.
He's not going to give you what? Oh, no, that's not what we're doing. It's actually a bit simpler than that, I think. Okay, so then what I'm going to do is expand this again. So that is a 672, whoops, I didn't write 2, 672x cubed, and this, oops, that's a minus. So then this is minus 896 x cubed. Okay, now what did I say that equals? All at the start, all right? So it equals 560. So what I'm going to do is just give myself a bit more room. So I'm going to now say that 560 equals, so that's the coefficient, right? So negative 560 plus 672a, because that's what this is, minus 896, right? These together must be 560 because that's the coefficient of x cubed. Yes? Right? So, because these three terms go together because they're like terms. So when I add them together, it's 3. It is. So 560 equals 2016. Negative 2016. Yeah, that's right.
It's 4/3.
Plus 6.
516 divided by 673.
Yeah, that's right. So then we get, oh, I've written it backwards. I've just skipped a couple of steps on my thing. All right, so then we have, what have I got? No, that's right. So then, oh, that's what I did wrong. Yeah, exactly. I need to add. So I'm going to add these two things over here. So then I get 2016 equals 672a, right? I'm just bringing those two across here. So then a is 3. All right, I know that was absolutely horrendous. So really, again, we're not learning anything new. We're just trying to use this intelligently and think about which parts of this are the bits that matter to me. How do I pull them out? How do I expand brackets? So when you have multiple things, always start with the one with the power. Then once you've expanded as much of it as you need, because you won't need to do it all, then you think about adding this in. Hopefully it'll be more of the other questions rather than this one, because the other one is way easier. Okay, I'm going to leave it there.